In this video, we're going to look at applications of exponential functions. In the first example, the problem reads, if you invest $5,250 in an account paying 6.38% compounded continuously, how much money will be in the account at the end of in A, 6.25 years and B, 17 years? The first thing to do this problem, we need to know the formula, and that is accumulated value, A, is equal to principal, or amount invested, times E raised to the rate times time. So here in part A, we have A is equal to P is 5,250, E times the rate, which is 6.38%, so I'm going to write it as 0.0638 times 6.25. And when we calculate this, we get A is equal to $7,822.30. And in part B, we're going to have the same setup, except for instead of 6.25, we're going to have 17. So it's going to be 5,250 e to the 0.0638 times 17. And when we calculate this, we find that the accumulated value is 15,530 and 85 cents. In the next example, it says a promissory note will pay 30,000 at maturity 10 years from now. How much should you pay for the note now if the note gains value at a rate of 6% compounded continuously? So for this problem, we're going to use the same formula as we used in the last problem. A is equal to P times E raised to the RT. Now the only difference is in the last problem they gave us P, they gave us the amount we were investing. In this problem, the 30,000 represents A, and it represents A, the accumulated value, 10 years from now. So we're going to have 30,000 is equal to P times E raised to the 0.06 times 10. So in this case, P is equal to 30,000 divided by E to the 0.6. And when you calculate this, P is equal to $16,464.35. So what this means is we need to invest $16,464.35 for 10 years if we're getting a rate of 6% compounded continuously, so that we have 30,000 at the end of that time. In the last example, it says a couple just had a new child. How much should they invest now at 6.25% compounded daily to have 100,000 for the child's education 17 years from now? Compute the answer to the nearest dollar. So similar to the last problem, they gave us A and we're trying to find P, but the one difference is now we're compounded daily. So instead of using A is equal to P times E raised to the RT, we're going to use A is equal to P times 1 plus R over M raised to the MT. Now M is the amount of times it's compounded per year, and that is, we're compounded daily, so 365. So here in this problem we know A, it's 100,000, and that's equal to P, which we're trying to solve, and we have 1 plus the rate, which is 6.25, so 0.0625, divided by M, which is 365, raised to the M, 365, times T, which is 17. So here we can say that P is equal to 100,000 divided by 1 plus 0.0625 divided by 365 raised to the 365 times 17. And when we calculate this to the nearest dollar, we get $34,562. So this couple needs to invest $34,562 at 6.25% compounded daily to have $100,000 for their child to go to school in 17 years. And that's all for this video on applications of exponential functions.